Hi, Rolf here, and thanks for joining me again this week. Well, it's that time of the year. Uh, Snow's melting, flowers are blooming, and building owners are starting to think about what their roofing program should look like for the new year. When we talk to our regular clients, we find that they have three primary areas of concern. Number one, that they're worried that their firms may not meet their sustainability and recycling goals. Number two, they're frustrated that if they put a new roof on, they may need to tear off the whole roof, and that all goes to the landfill. They're concerned about the waste going to the landfill. And number three, they're concerned if they do need to do a complete tear off, what kind of a budget impact is that going to have? Can they even afford to do it? So one methodology that's often used to try to mitigate those concerns or manage those is to have a roof moisture survey performed. So last year I shared with you a story from a client that in a previous year had an infrared scan done, and based upon that they were under the impression the entire roof was wet and needed to be replaced, and they were extremely disappointed at the end of the day after they let a contract, and over 300 dumpsters of dry insulation went to the landfill. Had a similar conversation here just a few days ago with another client that was going to have a capacitance survey done, and when we reviewed the roof that was going to be done on, it wasn't going to work. It's a technological push, and so for that reason I thought it would be good to revisit roof moisture surveys, the three primary technologies, and give you a brief overview of how they work. So, and the other thing I would caution people is that if you're speaking to a provider and they have one tool in their toolbox, they only do infrared, they only do nuclear, they only do capacitance, beware. That might not be the right tool for a specific application. So there's three methods to detect moisture in the roof: infrared, nuclear, capacitance. None of them measure water directly, but measure an attribute of water. So let's dive in. Infrared is by far the most common technology that's used. And what it does is it measures the surface temperature of the roof. The theory being that wet insulation in the roof retains heat and can be seen at night, or transmits heat through inefficient insulation, and that the infrared camera can see that. It's the most common method. It must be performed after dark, so the roof cools after sunset, and the infrared camera should be able to pick out the wet insulation. It can be done on the roof. It can be done from an aircraft. In the case on the roof is most common. There's a person with an infrared camera, and they would scan the roof, and there'd be somebody else standing on the roof with a paint stick marking out the wet areas. In the case of the person holding the paint can here, that would have been my son 20 years ago, paying for college. The speed is extremely fast. You can cover a lot of ground in a night, and because of that, the cost is low. But there are limitations. As for instance, ballasted roofs, the roof with the big rock on it, it's a technological push to get an infrared to work there. So you'd want to use it very selectively there, or look at one of the other systems. So that's infrared. The second is nuclear. It measures the hydrogen in the roof, hydrogen being part of H2O. This is done in the daytime. It's done on the roof with by laying out a grid, and workers go up there with gauges to take reading at every grid spacing. In the case of this guy, that would have been me 40 years ago, paying for college. Because it's all of those methodical readings are taken, it's extremely slow, and because of that, the cost is high. But the accuracy is high because you're taking readings on a consistent basis, and the tighter that grid is, the more accurate the scan is, the survey is. The good thing is it works on every type of commercial flat roofing system. So that's the highlight of nuclear. Capacitance measures the dielectric constant of the roof. And what is that? Dry roof insulation has a very low dielectric constant. Water has a very high dielectric constant. So as the capacitance meter takes readings, if there's water there, it'll pick it up and show it. It's similar to nuclear in that the work is done in the daytime. There's a grid laid out, and because same thing, you're taking all those methodical readings, it's slow and the cost tends to be high. It does not work. It's similar to a ballasted roof being a technological push for infrared. To use this on EPDM, for instance, is a technological push. So it may not be the right fit there. The other thing that I think it's good for is as a cross-check. It's very good at telling you how close moisture is in the roof system to the meter. You get a higher reading with a little bit of moisture below the membrane as opposed to more moisture down by the deck. So it's a good cross-check for infrared and nuclear. So at any rate, if you'd like to discuss more about the attributes of these systems and which are appropriate for the roof systems you have on your buildings, let me know. I'd enjoy having the conversation with you. In the meantime, I hope you all have a good week, and thanks for watching.